So without further ado, I think it's time for tonight's presentation and Passive House 101 from our super awesome colleague, Phil Schmidt, and fellow board member. A little bit about Phil. Phil has been a practicing architect in Chicago for 16 years. He was the project architect for Landon Bohm Baker on Chicago's first multifamily passive house project, the Lucha Tierra Linda Six Flat in Humboldt Park. At Figure Ground, which is his firm, he's been mostly focused on primarily on upgrading our existing building stock through deep energy retrofits for single family homes and large multifamily housing. Phil, I'm going to hand it over to you and just let everybody know that we are recording this. Take it away, Phil.
Cool. Okay, let me share my screen. Okay, can everybody see my screen? Is it working? Okay, cool. Yep. All right, yeah, thanks for that intro, Lindsay, and it was really great to go around the room and kind of see where everyone's coming from. I think this is an annual tradition we do. It's just called Phius 101. It's a great primer for Passive House and a really good refresher too. It's something we all probably need every year. So I'll just get started. I'm hoping we get a little time for discussion at the end too. Okay. So in this presentation, we're going to discuss what Phius is, what passive building is, how passive building is the best and first step towards net zero energy consumption for a building, and then also how to certify a project through Phius and what that process looks like, some of the key players along the way, and tools at our disposal. Okay, so what is Phius? It stands for Passive House Institute US, and it's headquartered conveniently here in Chicago. And the main goal of Phius is to drastically reduce building energy consumption through passive building, basically to change the way the ordinary way we build buildings. And Phius certifies buildings, it certifies people, and it certifies products. And then Phius works with other institutions like the Department of Energy and builds on programs that are already existing, like zero energy homes, indoor air plus, water sense, those kinds of things. And then Phius has another wing that's it's supported by, it's a community of educators, collaborators, kind of on a local level, and that's what we're doing tonight. That's the Phius Alliance. Phius Alliance Chicago is what we're doing tonight. Okay, so what is Phius? It's an organization that promotes a set of passive building standards and a certification process. And that certification process can be used for pretty much any building type. Single family homes, really common, multifamily residential, but also non-residential, commercial or industrial. And it's going to include new construction, it's going to include renovations. But really importantly, Phius isn't limited to houses. And I know passive house is in the name and comes up a lot when I'm talking to like clients or even really anybody. When I talk about passive house, they think I'm only talking about homes, and it really is so many different building types. And basically what passive building is, it's a method of flattening energy use. So both on an annual basis, the loads a building uses throughout the year, and then on a peak basis. In these two charts, you've got a typical building and a passive building, and you can see kind of in the red and the blue how that curve gets flattened. That's your energy use throughout the year. And then those peaks, like this looks like a heating load dominated climate, similar to Chicago. So you can see like the heating load in the winter goes way, way down, like that. Those peaks go down, and the cooling in the summer goes down. So it's going to reduce total energy consumption and peak power. And these are just a few of the big benefits of passive building. It's a super, I don't know. I think it's just the best way to build personally, but there's so many advantages to it. Part of it's like, the long-term affordability, the money you're going to save on, or the client will save on utility bills over time. Comfort comes up a lot, I think, especially when I'm talking to homeowners who get real fixated on like a really nice kitchen countertop or really nice cabinets, and those things are important. But I always think like, what's more luxurious than, super clean, fresh air, and I don't know, or like in the middle of like a winter in Chicago, being able to walk through your living room barefoot, stuff like that. Resiliency is something that's coming up a lot, kind of as we're starting to see in the present sense, we're seeing the effects of climate change, and if there's like a crazy blizzard, your home loses power for a couple days, a passive house is going to remain pretty comfortable even without, power or heat. It just kind of stays at a steady level. Here's some history of the passive building movement. Illinois is a big part of that history, both at the very beginning with the locale homes down in Champaign-Urbana, and then also in the last 10 years when passive building's seen a big resurgence in the US. It kind of started in 2002, I think, with Katrin Klingenberg. She designed and built the Smith House in Urbana, which kind of kickstarted the movement again. And then in 2015, Phius released a cost-optimized standard that has also really, really sped up the growth of passive house, because it's cost optimized. It's finding that point where what you're spending on a building, you see the results of pretty directly, and it's climate based. So it's, the US is such a big country that we have so many different climates. And what this 2015 standard does is it has specific requirements for each climate, basically. Okay, so passive building principles. The next few slides are going to go through kind of the basic principles, which are on the top of this circle in orange. And then on the following page, these are those principles. So thermal control, you're going to have a high performance enclosure with continuous super insulated envelope, minimize thermal bridging. And then air control, you're going to airtight construction to support balanced ventilation and heat recovery. And radiation control, it's going to be smart window placement, special attention paid to glazing, solar heat gain, shading strategies. So, and as a result of all these principles together, the heating and cooling mechanical equipment can be sized way down and the distribution gets less complex. So that's the passive part. Those are kind of the passive strategies. And then in a little more detail, continuous insulation. I think this graphic's really more about thermal bridging, because building codes are what dictate our minimum R values in a conventional building, but then a passive building is going to rely on specific energy modeling to determine what's the right amount of insulation to hit Phius goals. The image here is it's an infrared image showing heat loss, the series of row houses. The one in the middle is the passive building. So you can see the ones on the sides are just seeping out heat everywhere. The passive buildings in blue.
Yeah, I think the intent of that slide was that like the continuous exterior insulation is like a nice jacket over you, like it just provides that extra layer of thermal performance or thermal comfort. And I feel like we see that a lot in some of our passive house communications and things like that. So
yeah.
Yep.
Yeah, I think they use a sleeping bag. I see the jacket a lot.
Mm-hmm.
It's like, yeah.
Yep.
Okay, so a little more. This slide is more about thermal bridging. It's got a picture of the Aqua Tower, which everyone in Chicago probably knows. And just as a concept, thermal bridging is when conductive material passes without interruption from the interior to the exterior of a building. It's usually structural. And so thermal bridging is remedied by creating a thermal break. And I know a lot of people get those terms mixed up, the thermal bridge versus the thermal break, but I picture it as like a bridge where something's flowing across and the break stops it. So it stops that heat loss from leaving your building. Here's another infrared, kind of the same idea. And so the image on the image with all the green and all the red shows all those thermal bridge locations, windows, window headers, roof overhangs, that kind of stuff. And interestingly, in this, with the passive building and all the blue, you can see the windows are still kind of the weak spot. Like they're all in green, which isn't bad, but isn't great. So that's why we're really careful in passive building design, where windows go, what type of windows, and how they're all detailed. Optimized windows refers to the correct balance between heat loss through a window and heat gain through sun exposure. So it's going to be climate specific, building type specific, and orientation specific, like a south facing window in Chicago in the winter could be really helpful for solar gain, and it could be a kind of a hindrance in like Miami or something. So a passive building's still gonna have a lot of good windows, but they're going to be really, really carefully used, for view, for light, for solar heat gain. And you're probably not going to see a lot of floor to ceiling glass, though it is possible. So airtight construction is going to be really important. Just having the building sealed continuously all around the building, including the slab. And then so Phius is going to require passive buildings to be 5 times tighter than even what's required by code. And I think in my experience, it might be the most challenging part of constructing a passive building is all the air sealing, the floor, the ceiling, the windows, anything that penetrates the building envelope, and then doing that testing and getting to the passive house level. But this air tightness, it's gonna provide durability and support balanced ventilation. And it's going to make a big difference, between an airtight building and a leaky building. It's a big difference in energy use. So balanced ventilation, there's the controlled ventilation version is a passive house. And then random ventilation, that's the more conventional approach. And controlled ventilation, you've got an airtight building, you're choosing where that fresh air comes into a building. And in random ventilation, it's really impossible to predict where it's coming in or how much there is. It's, I like to think of it as like trying to breathe fresh air, but like through your walls and your ceiling, just wherever air happens to come in through a leak or a gap, and just breathing in whatever's in your walls. So balanced ventilation is the goal, and we're going to do that through HRVs and ERVs. It's heat recovery and enthalpy recovery. HRV is heat only. It's going to reclaim exhaust air on its way out and use that air to pre-treat the incoming fresh air. And an ERV does the same, but with humidity. And then as far as air infiltration, Phius uses already existing programs like EPA, Indoor Air Plus, and Zero Energy Home as co-requisites. So the goal, once you do all those passive measures, is to reduce the active space conditioning needs. So maybe instead of a furnace, you get to use a heat pump and an ERV, and it's they're much more efficient than your typical furnace. It's going to allow a building to go all electric, which makes it more energy efficient, improves indoor air quality, and in general, it's just good for decarbonization. Okay, optimization of passive measures. So the previous slides have been kind of more foundational parts of passive building. And the next few are the characteristics that help with cost optimization and a climate-specific path to certification. Okay, so with passive house, it all starts with energy conservation. We're trying to get those energy loads as low as possible before we bring in renewables, if we bring in renewables at all in the end. Okay, so the target setting method. There are 4 main certification requirements. Space conditioning targets, which are climate specific. that air tightness value we talked about. And then on-site QA/QC done by a third-party certified passive house rater. And then finally, a source energy target. So when we're setting these goals, basically since the 2015 version of Phius standard, they've tried more and more to find what we're calling the sweet spot. It's the maximum amount of financial investment before energy conservation kind of stops making sense. So it's basically like you could keep adding more insulation, but those upfront costs are not necessarily going to balance out with the money you save on your utility bill later on. So that's really been the goal, and maybe why passive house is kind of taking off in popularity is because they have found that sweet spot where it makes a lot more financial sense. And then I also think, not on this chart, but the maintenance cost can be kind of difficult to quantify and predict as the building ages, but in general, an airtight building with less thermal bridging is just going to be more durable and deteriorate slower, last, decades, So more about that sweet spot. This is a graphic showing all the different climate sets, data sets for the US. So in Chicago, we're climate zone 5, we're in the green, but I think Phius has over 1,000 individual sets. So basically wherever you're building in the country, you can do that cost optimization exercise. Okay, so in addition to climate-specific space conditioning targets, Phius certifications ensures the highest quality building envelope. So it's the other thing we're kind of publicizing is this is just a better way to build. You're going to get a better end product. Okay, so to talk a little bit about the QA/QC, like I said, Phius does build on pretty robust programs from the Department of Energy that are already in place. And basically the QA/QC process, it's just about making sure what gets certified is what was drawn, what was designed by the design team, what was approved by Phius, and then ensuring that end user or homeowner or client gets the product they wanted to pay for in the end. Okay, this is the high performance staircase. So this shows other co-requisite programs from the Department of Energy, and then just kind of in general comparing it to maybe a code-built home on the far left there, Energy Star and then Zero Energy Ready, and how Phius Core and then Phius Zero builds on that. Okay, so now we get into, this is more like Phius Zero. This is, you've done all the energy saving you can through conservation and passive means, getting the rest of the way to zero if one chooses to go that route. You do that with renewable energy, either on-site or off-site. And then this slide shows kind of how Phius thinks about energy. It's not just about the energy used on the site that a specific building uses, the lighting, heating, cooling, all that stuff. Phius also takes into account what they call source energy, and that's going to be all the energy it takes to produce that electricity in that particular building. So, and not only produce, but deliver to your site from wherever it's coming from. So it's kind of more the real energy impact we're looking for. And I know that's constantly changing as our grid gets cleaner and cleaner. I think when I took my CPHC course, there was like a ×3 multiplier factor, like anything you used in your building was actually really using 3 times that just to get to the building, which is kind of mind-blowing. So the final certification requirement is a net source energy target, and that net is going to be, it's the net of renewable energy production. So source energy targets are set differently based on residential or non-residential use. So residential, it's a per person value that you have to stay under, and then commercial or non-residential, they do per square foot. So again, it's like step 1 is conservation, step 2 is renewable energy. And then once we reduce those loads, the idea is that less renewable energy is needed. It's really important just in general to consider the impact of a building beyond the site that you're on and, you know, into the whole electric grid. Okay, so we've got net source energy. This is comparing your baseline conventional building, a Phius core building without renewables, and then adding renewable energy to that to get to Phius 0. And then, you know, Phius 0, as the name implies, you're either trying to get to 0 or net positive even, might actually generate some more electricity than you need. Let's see. So this is the Phius certification framework. At the base level, the most important thing is all the quality elements, basically. An airtight building with moisture control, it's durable. And then on top of that, your passive conservation strategies, they're going to reduce space conditioning needs. And then your active strategies, maybe heat pumps instead of furnaces. You get to use ERVs, things that are more efficient, use less energy. So that's the basic program, that's Phius core. You can get certified at that level. Or you can take it further, do on-site renewable and some off-site renewable, and that's how you get to Phius 0. And then a pretty new kind of alternate approach to Phius core. We've been talking about performance paths up to this point, where you do an energy model and you basically model everything to figure out how to get to those Phius targets. So Phius, just to kind of make things more streamlined, and you get more people interested, they introduced a prescriptive path in 2021. The scope it's going to be limited to single family homes, and they have to be all electric. It's going to follow the basic tenets of the baseline Phius core. Oops. So we're not even talking about renewables or anything like that. But you know, instead of performance, we're going to be following prescriptive rules and guidelines to get there. Okay, so here's an overview of that prescriptive path. The items in gray are the general scope, and then in navy blue, these are passive conservation strategies, and then the teal are the active strategies. And so the ones in the navy and the teal are going to be building specific and climate specific, but the ones in gray are general and would have to be followed by anything going for prescriptive. This is a really cool tool on the Phius website. It's the snapshot tool for Phius prescriptive. It's going to tell you recommended R values, U values for windows, minimum mechanical efficiencies, all based on the project location, the size of the building, and the occupancy. And it's a really nice tool. It's actually even fun to use, I think, for the performance path. If you just want like a quick reference, kind of a rule of thumb, like, you know, do I want an R35 wall, or should I be shooting for an R45? Just the very beginning of a project kind of thing. Okay, so let's talk a little bit about the process itself. Assembling your team. So the certified passive house consultant and the rater or verifier are both required on the team, have to be on every project. The consultant, the passive house consultant, is going to work more on the design, the energy model, submitting the project, and then the rater verifier is going to do QA/QC and all the testing on site. And then in the middle there, It's also strongly recommended to use a passive certified builder. And then I think just in my experience, the most important thing is getting everybody involved early and talking to each other, because this is it's a non-standard at this point, non-standard way of building, and it takes some buy-in from people. It's really best if everybody on the team is enthusiastic and like genuinely interested in passive building there voluntarily and that kind of thing. So each member of the team should be familiar with the certification guidelines, things like moisture control, comfort assessments for windows, design requirements for ventilation systems. Those are kind of the basics. This slide's talking a little bit about the software. We use WUFI, W-U-F-I. It's an essential tool for energy modeling, for getting your project certified. It's going to do a whole building energy simulation to determine specific annual heating and cooling demand, and then verify that your design hits those Phius targets. And all those Phius targets are included within the software, where you can kind of customize it for your climate and everything. But it's within the software, so it's a really handy tool. And then in addition to that, there are other tools like Therm. If you have a Therm you could use if you had a concern about a particular thermal bridge, you can, in one of your details, you could test it there. And then WUFI Pro has other functions, like you can test a roof or wall assembly and see you can analyze heat and moisture, see how likely it is to grow mold, that kind of thing. It gets pretty technical at that point, but WUFI does offer those capabilities. Okay, so the next few slides are going to provide a general overview of the certification process, broken into two parts: design certification and final certification. Design certification is going to ideally happen before construction and basically make sure everything in the project is on track to hit those Phius targets. And then final certification happens during or after construction, and that's where the Phius rater gets involved usually. Okay, so we'll go through a few different phases of the process. This is phase 0. This is optional. You can do a feasibility study. It's recommended for any project before committing to a certification contract. A CPHC can do one of these, or Phius can do them. It's basically a pretty quick energy model to see how close you can get to Phius levels. Okay, so phase 1, paperwork. This is basically getting your project in the database, getting your contract signed, paying your fee, kind of all those kind of admin things at the beginning. And then you'll see also in the little gray box there, the kind of architectural phase or construction phase that corresponds to. So this is pre-design or schematic, is when you would probably want to do these. Phase 2 is the design phase. That's when you start your modeling, you do your design certification. Yeah, and again, ideal to do this before construction. Suppose that should probably make sense to anybody in the construction industry. You never want to have to like change things while your building's under construction. Phase 3 is construction. Your Phius rater is going to start making periodic site visits and just make sure it's getting built the way it was designed and approved. And then you get your final certification after construction finishes. So these are kind of showing, these are snapshots of the state of passive building in the US. You can see just that this is like the last 8 or 9 years, and it's just been an incredible growth curve. And then parts of the US where I guess the states that are the darker blue are the ones that are where it's really exploding. Like I know it's really big in New England, New York, Pacific Northwest, and then Illinois and California. So this is a really exciting graph. It's like we're definitely moving in the right direction. It's a pretty exciting time. Resources and training, there's just so much available. The guidebook itself is super thorough. It's a great way to walk through the process. Most questions can be answered straight from the guidebook. And then the people at Phius are also super responsive through email with questions. Like they very much want to help, and questions are going to come up along the way. And they're just a great resource. I think maybe a year and a half ago, Phius redid their website. It's really easy to use, packed with lots of calculators and resources, and I highly recommend everybody check that out. There's also a project database, which is a good way to look around, see what other people are doing in your region. I've even looked at it just if, I'm working in an unfamiliar region and I want to see, have they built passive houses here before? And if so, who are the contractors that worked on it? Or, do they want to work on it again? Or they, if they've done their first one, do they want to do a second one? That kind of thing. And then again, Phius does offer feasibility studies with a pretty quick turnaround. That's pretty impressive. They're going to take a preliminary energy model of a building. Phius offers this service directly, and it's based on building size, how much the fee is. And then a CPHC can do this too. And it's good to have a basic building mass started for this energy model. So these are some of the professional trainings offered. I've taken the CPHC course. I recommend it. I recommend the training. It's just a great way to dive in. I had worked on a passive building as an architect, and then found the learning curve kind of steep in the beginning. And then I thought, oh, maybe I'll get certified. And then I learned so much from the training, and it's really, I don't know, kind of changed my practice. There are also, on top of that, once you get certified, there's so many webinars and extra courses to take to keep your skill set fresh and learn more. I took the advanced single family training, I think during like peak COVID, and it was fully remote and really, really helpful and convenient. I just did it at home. And then Passive House US Alliance, just again, what we're doing tonight. We'd love to see you all at our meetings. It's about building a community of kind of like-minded folks. And then so Phius Alliance, it's a nonprofit. It's a great way to get involved locally, nationally. And then at the Chicago Alliance, we do these meetups, as we said, monthly via Zoom. Sometimes we have in-person events. It's always the third Wednesday of the month. And we'd love to see you there. I think that's it. So thanks, everybody. That was a lot of slides. And I know we want to get into some discussion too, but I'm really, really grateful everybody came tonight, and I'm excited to talk more. Thanks.
Thanks, Phil. This is Jennifer. I'm stepping in. Lindsay had to run out for an appointment, so I don't see any questions in the chat, but just, yeah, if anyone has any questions, you can either write them or feel free to just start talking, I guess.
A quick question on the Woofy software. Is Woofy the software that needs to be used for this certification, or can you use, a variety of energy modeling software?
Yeah, it is required. Yeah.
Okay, that's the one. Okay, perfect. Thank you.
Yeah, but it does have like a SketchUp interface. That's where usually the modeling happens, and then that imports into Woofy. So.
Okay, good to know.
Yeah.
Thank you.
Yeah.
I had a quick question on the prescriptive method. If you do the prescriptive method, are those resources out already, and is that free? And then do you not need to do the energy model? Do you not need to do the Woofy?
Yeah, you don't need to do the energy model. It still is going to cost, like Phius is still going to charge a fee to submit, but I think it is a reduced fee. I'm not sure. I actually haven't done one yet through that, but it sounds
That
really
was
interesting.
only for single family homes.
Yeah, exactly.
we are a little bit past 6 now, so I guess we'll wrap up. If anyone has any other questions, feel free to paste them or sorry, put them in the chat for the event. This is recorded, so we'll be posting it within the next couple of days. And then some of the questions that I wrote down, I will also post on the event page. So thank you again, Phil. That was awesome. Thank you everyone for coming, and we will hopefully see you next month.
Thank you.
Thank you.
Yeah, thanks everybody.